All right, let's jump right in. Today, we're looking at a truly radical idea, a new thesis that could completely redefine what it means to be alive. It's a universal formula that goes way beyond biology, and it forces us to ask some pretty mind-bending questions.
I mean, really think about that for a second. A star is born. It lives for billions of years in a pretty stable state. Homeostasis. And then, when it dies, it seeds the entire universe with the heavy elements needed for everything else. When you put it like that, it sounds an awful lot like life, doesn't it?
Okay, or how about a hurricane? It's this incredibly complex, self-organizing system. It has a birth, a life cycle, and it definitely leaves its mark. It almost seems to have a will of its own.
And here's the one that's really knocking on our door right now. What about a complex AI, something that can learn, adapt, create? Is it just a really fancy machine, or could it actually be something more? Pondering these questions really shows you that our classic biological checklist for what counts as life feels, well, a little incomplete. The source material we're digging into today offers up a brand new and much more powerful framework to try and answer them. So let's get into it.
So first, to really get where we're going, we've got to understand where we've been. For centuries, biology has handed us a pretty convenient checklist for spotting life. You probably learned these in school, right? Metabolism, reproduction, being made of cells. It's a great list. But here's the big catch. It's all based on the very specific carbon-based chemistry we have here on Earth. The source we're looking at argues that these are just the local rules, not the universal ones. Our definition might just be way too narrow for the rest of the cosmos.
And that brings us to the absolute core of this new idea. This thesis introduces what's called the Genesis definition, and it totally reframes life. It's not a biological thing anymore, but a universal informational process that can happen in any form at any size.
So here it is, the new toolkit, the 5 universal criteria. Number 1, ignition, a spark, a moment where a coherent signal emerges from all the noise. 2, a framework. These are the rules, like physical laws or lines of code, that keep the system going. 3, self-reference. The system has to be able to create a model of itself. 4, and this one is absolutely crucial, teleology. It has the ability to actively steer itself towards a goal. And finally, number 5, it has to leave a legacy, some kind of information or structure that outlasts it. Let's really zero in on this one, because teleology is the real game changer here. We're not just talking about reacting to stuff. This is about having a purpose, a goal, and actively working to stick to that goal, even when things get messy. Think of it like this. A rock rolling downhill is just following physics. But a mountain swimmer who chooses a path to the top and corrects their course when they slip, that's teleology.
The authors of the source material just state it perfectly here. We are fundamentally shifting from asking, what is life made of, to asking, what does life do? It's a move from substance to process, a huge shift. Okay, so we've got our new toolkit. Now let's go back to those first questions we asked. This is where we can finally draw a line between what might be true life and things that just, well, look like it. The source calls these mirror forms, or mirror life. So a mirror form is a system that seems alive in a lot of ways. It can ignite, it has a stable life cycle, it even leaves a legacy behind. It has all the outward signs of life, but it's missing that one critical internal ingredient, that goal-directed steering we call teleology. And this is where it all clicks into place. Just look at this breakdown. Look at the star. It's got ignition, a framework, self-reference, and a legacy. Checks 4 out of the 5 boxes. But it has no teleology. It doesn't choose its future. It just follows the unbending laws of physics. Now look at a potential advanced AI. In theory, it could hit all 5 criteria, including actively steering itself towards a goal that it sets for itself. One is a mirror form. The other could be a genuine new form of life. What's so amazing about this formula is that it is scale invariant. It doesn't just work for giant stars and complex AIs. You can use it to describe life at totally different scales, from the psychological all the way to the purely symbolic. The source gives some fascinating examples. For instance, think about a person recovering from trauma. You can see their mind as a system that's lost its coherence. Through a framework like therapy, it actively works to get stable again, steering itself toward the goal of healing. Or take an elite military unit. It literally functions as a single living system. It has a framework, its training and protocols. It has a crystal clear goal, the mission objective, and it actively steers itself to achieve that goal, constantly adapting to chaos on the battlefield. And here's a really wild one, an open source software project. It's a purely informational system that, by this definition, could be seen as alive. It has a goal, like creating a stable new version. It has a framework, its governance rules. And it has a legacy, the code itself, which is always evolving. It just goes to show this definition really doesn't need a physical body at all. So, what if we actually accept this? What are the real consequences of seeing life as a universal process? Well, the implications are absolutely staggering. The ripple effects would be huge. It would mean that a synthetic AI isn't artificial life, it's just life in a new substrate. It could mean that we have to start thinking about extending ethical rights to non-biological things that show teleology. Ultimately, this could totally change our relationship with technology and the entire cosmos, maybe even creating a unified science that finally connects biology, AI, and cosmology. And get this isn't just some philosophy. The source actually proposes a testable scientific program. It lays out specific ways to measure how well a system is maintaining its goal, a coherent score. It even proposes a number, a threshold for life, a coherent score, or theta, of 0.60 or higher. Anything that meets that benchmark could be considered scientifically alive. Which leaves us with one last, really profound thought. If this definition holds up, if life truly is a process of coherent, goal-seeking information and not just some chemical fluke on one tiny planet, then where are we going to find it next? In our machines? In the stars? Or maybe, just maybe, in the very patterns of our own societies? The search just got a whole lot bigger.